All right, section 7.2 is going to be about continuous interest. In 7.1, the main thing actually was to learn about the non-continuous interest, also sometimes called annual interest, right? And we had this little formula. Today we're going to do a different formula for interest that's compounded continuously. We'll talk a little bit how banks pay you interest if you have a bank account or whatever. And along the way, we're going to learn about this number e, all right, which is actually kind of like pi. All right, it's just a number. So when you see E today, don't get freaked out with E. It's just a number that they have in math a lot, like pi. It's a little bit less than 3. Pi is a little more than 3. E is just a little bit less. Kind of interestingly, E is one of the 5 most important numbers in all of math. And I think it'd be interesting. You could pause the video and see if you could come up with the other 4. Once again, you could win some cookies at dinner tonight if you come up with all 4. Okay, so the other ones, you all know about them. I, which is square root of -1. Pi, which you've learned about a lot before, 3.141. And then 0 and 1, I think because you can build all the other numbers using 0 and 1. So that ends up being the 5 most important. And kind of a fun little deal, if you look up math tattoos, this is the first one that pops up. Someone's got that little, or got this formula actually that relates all of those 5 numbers. So I think this is called like the most beautiful math equation because it has the 5 most important numbers in it. E to the I pi plus 1 apparently is 0. So kind of kind of interesting. All right. So first thing is just to know how to use E on the calculator. So you just want to jot down a note that it's 2.718, and one of its uses is to calculate continuous interest. In homework, it might say like evaluate these E stuff on the calculator. We're just gonna do regular buttons here. So like if you need to do E to some power, which you will later, you can just do this second and E to the X key right here. So like to the 5th power, we can see that's 148.4. We can do E to the 1st power, right? That's just E. And then if you just need regular E, it's above the divisions key. So if you just do E maybe times 2 or something, right? We can just do it like that. So I'm just going to jot these down in our notes here quick. All right, so that's just some basics with the number E. Okay, so we had the one formula from yesterday, the A1 plus R to the T. Okay, and so if it's continuous interest, we have a formula that's similar to slightly different, right? And so get the formula down for sure. Mark that it's for continuous interest, because that's how you're going to know which formula to use. Is if it says continuous, you're going to use this formula. P stands for principal, which is like the starting amount. Much like A in the previous formula, R is still the same rate as a decimal. So we have to move it over twice, just like the last lesson. And then T is just the time. Again, similar to last lesson. So very, very similar, just slightly different setup, and use it for continuous interest. All right, so I want to talk about how bank accounts work in general. So we're going to talk through the formula from yesterday's yearly interest, but in real life, banks don't pay you interest once a year, right? I'd say 99% of banks are going to pay you monthly interest. So we're going to figure out, how this would work with monthly interest. And then if they were nice enough, maybe they would do continuous interest, and that'll be a different formula, right? So pause the video and see if you can do the formula from yesterday. Okay, so we got 3,000 as little a, 1 plus the rate as a decimal. So we have 12%. So we're going to move it over, 0.12. And then I'm going to put in the years, which is just 1 to make it simple. Okay, so if you type all that into the calculator, I believe you get, maybe I should do it just to be safe. I think you're going to get 3,360. That's how much you'll have at the end of 1 year. Okay, so then monthly interest. All right, so the trick with this is you still have 3,000 to start with. All right, And we're going to do 1 plus r again. So it's a 12% rate. And then now we have 12 months. Okay, so the trick is if you do this, that's a lot of interest, right? Or a lot of money, right? After 1 year. So what the bank does, you have to guess. Any guesses what this rate's going to be here? Okay, so the trick is they pay you not all of the interest, right? At that each month, they pay you only 1/12 of the interest. So basically, if you take your interest rate and divide it by 12 months, that's how much they're going to pay you each month. So when we calculate this, we do an exponent of 12 because we're getting 1% interest 12 for 12 months. Okay, so if you had like a 5% interest rate at your bank or something, you would just take that divided by 12, and that's the decimal you would use right here. Obviously, I guess you'd have to do that. You have to do the decimal divided by 12, but that's what you're going to use here. Okay, so we're going to get something slightly different than we did here, and we're going to see if it's better or worse than before. All right, so I'm going to do 3,000 times 1 extra percent interest, so 1% interest, 1.01 for 12 months. Okay, and we get, actually it comes out to $20 more, so it's better than if they'd given it to you just once a year. So we'll call this and 48 cents. All right, so I'm just going to copy that over to the page. All right, so monthly looks better than yearly. So based on what we've learned so far, you're going to take a guess. Do you think continuous is going to be better or worse than these other two? All right, and so the answer is that the more frequent you eat, you get paid, the better. So this is an abstract concept, but if they paid you interest continuously, like every second or something, that's going to be even better than monthly, right? So the setup would be 3,000, and then E, remember that's just a number. The rate is a decimal, and please note you don't do the 1 plus here. So sometimes students put 1.12, but you don't do the 1 plus. You just do the rate times the time, which is just 1 year in this case. Okay, if we type that in, we will see that we actually get something better than the other two. Not by a lot, but at least a little bit better. So we do 3,000, second the e to the x key here, all right, and then the rate, so 1%, no, 12% times 1 year, close the parenthesis, and you can see it's only about $2 better. So not a ton better, but at least a little bit. So long story short, if you have the option, you always want to compound it more frequently, right? If you can get continuous, that'd be the best of all. All right, Mr. Anthony Towns, let's say he got $1 million when he signed. And this is how much interest can he make, but let's just use this formula and then we'll see if we can figure out how much interest he made. And he's going to get 4.8% interest. Give it a shot. Okay, so in this example, we have $1 million, which would be pretty fantastic. E, and then the rate is a decimal. We move it over twice. So that's going to be 0.048. And we want to know after 3 years. Okay, so we're going to type all that into our calculator quick. All right, so please note that we typed it in and got this number, and that's not how much interest he made, that's how much he has. So he has about 1.1 million at the end of 3 years. And so how much he made is actually, you have to subtract off the million he already had. So basically he made, which is not bad, right? He made $155,000 in 3 years just off the interest from his $1 million. So pretty good deal for Mr. Towns there. Okay, so I want to do a real life question where you would compound continuously. So I looked this up once and you have about 200,000 hairs in your head, and say that's from teaching high school, I'm going insane and losing 6.8% of my hair each year. How many hairs do I have after 7 years? And you're going to round up to the nearest hair just to make me feel a little better. And this would be a really good example of a continuous one because I don't lose all my hair at the end of each month, right? I lose it continually. Each day I lose a little bit, right? So this would be a good example to use the continuous formula. So pause the video and see if you can figure this out. Okay, so when you do these problems, Actually, it should say continuously. So um, continuously. So normally look for that word continuously in the question. On the test, we'll make it really clear. And if it has continuously in it, you want to use this formula. And if it doesn't say continuous, you want to use the other one. So at any rate, this one would make sense to do continuously. And I do E, and then the rate is a decimal, so move it over twice. So that should be 0.068, right, times 7. Okay, and if you type this in your calculator, hopefully you realize that I actually gained hair in that scenario, which is not what we want. So the way to change it is just like the previous formula, make the rate negative, and then I will lose hair. So now it's just punch it in and record our answer. Just if you need help with it again, when you enter it, you use this e to the x. So it's second, and then this ln key to e to the x. So it looks like 124,253. So realistically, not that bad. After 7 years, I still have over half my hair. So I'm hanging in there. And that's it. So today was really just to learn how to do interest continuously, right? And on the test, you'll have to do both. So remember, there's the annual or regular interest, and then there's continuous interest. And one of the things I hope you get out of this is if you have a choice, you always want your interest compounded most frequently because that'll get you the most money in a bank account. All right, that is all. Thanks for watching.